Hey y'all, it's Mrs. Madsen. Guess what? It's review day. If you can remember, if your trail is truly paved, then this might be one of the easiest days that you will have. If your trail is not paved with concepts from chapter 1, then this will be a good opportunity to go through and practice these concepts again so that your trail will be paved. So, the plan today is I will show you a question. You'll work it out and then you'll check back with me to see if you got it correct. We are going to review everything. What happened to my screen? Come back. Oh no. You're going to see this cool like Viking sculpture from Iceland. Fun fact, when I was in 6th grade, I had to do a big report on Iceland, and I even met with someone who lived in Iceland who was going to school at Utah State, and I interviewed them and they told me all about Iceland. And since then, Iceland is on my bucket list. And so I love Iceland, but guess what? It's just spinning around. Are we in? We are back. All right, so let's get started with the first question. The first question is an addition question. Now, how do we add decimals? The very most important thing, and hopefully the very first thing that came to your head, was we line up the decimals. So when I rewrite this problem, I am going to think, all right, if the decimal is not in sight, then I put it on the right. There's always an invisible decimal behind every whole number, just that we get lazy and we don't put it there. But there always is a decimal at the end. And then I'll line it up with the other decimal. I'm going to move my face to go over there. And now I can add that up. Now, I am totally okay with adding zeros, right? Because $345 is the same thing as $345 and 0 cents, correct? So I'm okay adding zeros behind the decimal. So when I add this up, I get 379 and 13 hundredths. So that is a good reminder of how to add decimals. We line them up. Let's talk about our next question, which is to subtract decimals. Again, we need to make sure we line it up. And if the decimal's not in sight, then we put it on the right. So we'll put 87 here on the right. We'll line it up with the decimals over here. And we will add those zeros. And here we go. We're going to subtract. Now, if I have 0 pennies, I can't take 2 pennies away, can I? And if I have 0 dimes, I can't steal from 0 dimes. But if I have $7, I can steal from $7. I'm going to steal $1, and that means I'll have $6 left. And now I will have 10 dimes. And if I have 10 dimes, that means I have enough to steal at least 1 dime. And that 1 dime I can change into 10 pennies. So I have 10 pennies, take away 2 pennies, and that leaves me with 8 pennies. 9 pennies minus 9 dimes minus another 9 dimes gives me 0 dimes. And then 6 minus 4 is $2. 8 minus 3 is 5. So I get 52 and 8 hundredths. Or if you want to think money, $52 and 8 cents. So again, with that subtraction, line up those decimals and make sure you regroup so you have enough in your top number, first number, to then subtract from the bottom. Next problem, we are going to divide. This is a divide decimals with decimals, which we can totally do. The first number always goes inside. By the way, you should have already paused and tried this problem on your own. And now you're just checking to see if I make any mistakes, which I probably will before the video is over. So I'm going to scoop out. So I have a whole number in my divisor. but if I scoop my divisor, I need to scoop my dividend. So it ends up being, let's erase this right here. Oh, that's a big eraser. Oops. It ends up being 15 into, that's ugly, I'm sorry, I'm gonna have to fix that too. 15 into 5,178. So if I have 5, that will not go in with 15, but 51 will. Over here, I think it's going to be 3 times. 3, 4, 5, 6, 7, 75. Oh, that's too big. Okay, let's try twice. Hold up. I did that wrong. That's estimating in my head. I was like, that's not right. All right, let's try that again. 15 times 3. It's only 15. 3, 4, 45. I'm going with that. So now I have 45. And I'm going to subtract there. I'm going to have to regroup and make it 11. 11 minus 5 is 6. 4 minus 4 is 0. Bring down the 7. And now I'm going to restart the whole process. If I have 67, can I divide into 15? Yes. And I think it might be more than 3 times. Let's see. Ooh, yeah. That'll be pretty. That'll give me 60. Remainder of 7. Bring down the 8. And I'm going to get even higher. Let's try 5. I believe 5 is 75. But let's see. Yep, it is 75. I'm going with that. And I have a remainder. I have a remainder of 3. So what I'm going to do now is add a decimal and a 0 at the end, because that doesn't change the number at all, right? It is still 5,178, but now I'm just saying, look, I have no dimes. So it doesn't change my number. It's totally okay to do that. What it does is it helps me bring down another number to figure out what my decimal remainder portion of the problem is. 15 will go into 30 twice, because 15 times 3 is 30. So I have no remainder. So the answer is 345.2. Okay, good. Did that go over me or under me? Oops, sorry. There we go. There you see it. Awesome. Next problem is multiplication. When we multiply, we do not line up our decimals. Instead, we want the 3 and the 6 to line up on top of each other. So I'm going to go 1.46, 4.3. When I multiply decimals, I'm even okay if once I have my decimals there, I just kind of ignore them for the time being. We will get back to it. So I'm going to times everything by 3. 3 times 6 is 18. 3 times 4 is 12, plus 1 is 13. 3 times 1 plus 1 is 4. Now it's time to times everything by this 4. But this 4 is not really 4, is it? It's actually 40. It's the 40 part of 43. So I'm going to put that 0 on the end to begin with. 4 times 6 is 24. 4 times 4 is 16, 17, 18. 4 times 1 is 4, plus 1 is 5. Add that up, I get 8, 7, 12, and 6. Now, if I were to estimate this, I could round this to 1, round this to 4. 1 times 4 equals 4. So my estimate, my real answer should be something close to 4. So if I were just to circle this and say my answer is 6,278, that would be way wrong. So now we're going to go back to the decimals. There was a decimal between the 1 and the 4, and the 4 and the 3. So now I'm going to count. There is 1, 2, 3 numbers behind those decimals. So I'm going to scoop 1, 2, 3 numbers in. So my real answer is 6.278, which is very close. to my estimate of 4, right? Way closer than 6,000 or even 62 or 600. 6 is very close to 4 if you consider it that way. So that is how you multiply decimals. Line them up all the way to the right and then scoop your decimal in. Moving on. Rewrite 15 plus 45. Oh, let's move my face over. Rewrite 15 plus 45 using greatest common factor and the distributive property. Two things I need to go through my brain again and see if how paved that trail is, right? How well do I remember greatest common factor? Well, what I was trying to get you to remember is that anytime I hear greatest common factor, I think birthday cake. And anytime I hear distributive property, I think of the angry bird, right? I think of a bird that's going to get shot through to 2 pigs. So it wants me to rewrite this. So don't just go 15 plus 45. It doesn't say solve, it just says rewrite. So I'm going to change this to be in the angry bird format. All right, so I'm going to start by finding that greatest common factor. I know that both of those end in 5, right? So I know I can pull out a 5. That would then be 5 times 3 and 5 times 9. Birthday, cake that up. And if I have a 3 and a 9, both of those are divisible by 3. So that leaves me with 1 and 3, and that is all for my common factors. So some of you on the pretest did something like this, 5 times 3 plus 9. And I only gave you half points because yes, this is the angry bird, but it's not the GCF. It's not the greatest common factor. 5 is just a common factor. In order to get the greatest common factor, I'm going to times those two together, and that is going to give me 15. And then 15 times 1 plus 3. And then to check that, I could go 15 times 1 is 15. 15 times 3 is 45. So I know that I've done it correctly. Basically, what I'm saying is that, like, hey, look, with both 15 and 45, they both have 15 as a common factor, don't they? Yeah, so that is why 15 became our angry bird. And we'll see the other factors inside are the pigs. So again, it's 15 times 1 plus 3. Good, good. This is so good to go through over and over again, huh? All right, the next problem is what is the least common multiple of 6 and 5? All right, least means smallest, common means they're the same. And then multiples, the multiplication chart. So multiples are like your skip counting, 2, 4, 6, 8. So I'm going to take those two and I'm going to list out the multiples until I come across a common multiple. So 6, 12, 18, 24, 30, 36, and maybe that will be enough because now I have 15. 15 plus 15 is 30, and I'm going to stop right there because I'm looking for the least. I'm going to have more common multiples, but 30 is my least common multiple. So that is the correct answer. What is the prime factorization of 48? Prime factorization? Did I even learn this year? The answer is yes. Yes, you did. Let's think about this. What are prime numbers? Prime numbers are those numbers where the only two numbers I can times together are 1 and 7. Okay, so my answer must have something to do with like prime numbers, right? And then factors are the two numbers that we times together. So prime factorization, let's see if I can get 48 into just prime numbers. And the way I will do that is by finding factors of 48. Now you can use any factors you want, and then you'll just factor it down until all you're left with are prime numbers. So with 48, the two numbers I'm thinking of are 4 times 12. And then with 4, I know that I can go 2 times 2. I know 2 is prime because all I can do is 2 times 1, right? So I don't even need to put that. I just know I can circle those 2 2's because 2 is prime. Now with 12, 12 is not prime because I know I can go 2 times 6. One thing I hope you did not do is go 6, 6, right? 6 times 6 are factors for 36, not for 12. We are not adding, we are timesing these numbers together. So back to this, 2 is prime, and 2 factors for 6 are 3 times 2, and both of those are prime. So the last thing I need to do is I need to list these out in order from least to greatest. 2 times 2 times 2 times 2 times 3. Okay, and I can times them together to check to see if it does equal 48. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48. I'm acting super confident, but I actually don't know. So 16 times 3 is, yep, 48. Okay, so that is the correct prime factorization of 48. If you want to somehow remember and think in your head, prime factorization is this Christmas tree. If you can figure out a way to remember prime, prime. I don't know, whatever your brain needs to help you remember prime factorization, get it down to only the prime numbers. There you go. The number 678 is divisible by what number? Divisible is another word that means like divided by, right? So it's basically asking what can we divide by 678 and not have any remainders? All right, I know that it is divisible by 2 because it ends in a 2, 4, 6, 8, or 0. Basically, it ends in an even number. So yes, it ends in an 8. It is divisible by 2. Now, 5 is another really easy one. 5 and 10, 2, 5, and 10 are my favorite ones to check because they're the easiest. All you have to do is look at how they end. It is divisible by 5 if it ends in a 5 or 0, which this ends in an 8, so it's not divisible by 5. And then 10 is even easier. It's got to end in a 0. This does not end in a 0, so it's not divisible by 5 or by 10. Okay? Then, if you want to get even better, you can think of like 3 and 9. 3 and 9 are similar. You find the sum, and that means you add. So if we add 6 plus 7 plus 8, that gives us 21. And guess what? 21 is divisible by 3. So that means this whole entire number is divisible by 3. And you might be like, really? Are you really? It really can be divided by 3? Yeah, look. I'll even prove it. Oh my gosh, look at this. It goes in evenly with no remainder. Oh man, you can't even see that. Get out of the way, Mrs. Madsen. Okay, do you see how it went in evenly? I just proved it, but just by adding up the digits and seeing that the sum was a multiple of 3, I could have already told you that it was divisible by 3. Now with 9, it's the same thing. You have to find the sum, which means add, but then that sum has to be divisible by 9. So let's do that same problem. But this time, let's divide it by 9. First of all, okay, hold on. We can figure it out. You can already be like, Miss Madsen, it will not work because 21 is not a multiple of 9. Okay, again, get out of the way. Okay, there we go. 21 divided by 9 does not work. So before I even try the problem, you'll be able to say, no, Miss Smith, no, it's not gonna work. And be like, well, let's prove it, right? I'm gonna go 7 because that's 63. Get a remainder of 4, bring down the 8. 9 will go into 48 5 times. Oh, bother. You're right, look, there's your remainder. 75 remainder 3. So I just proved that, yeah, it's not divisible by 9, but we knew it just from adding up the digits, 6 plus 7 plus 8, and seeing that that was not a multiple of 9. So that, my friends, is how you find out if a number is divisible. I just start with the 2, 5, and 10 because they're the easiest, and then I might go into 3 and 9. Okay? Put the numbers in order from least to greatest. It's the final question. With these decimals, the most important thing when we compare an order is to line them up. Compare all the whole numbers, then compare all the tenths, hundredths, and thousandths. So I'm not really even going to look at these until I get them in order, until I line them up. I don't know the order yet, but I can't really compare them very well by looking at them. But I can compare them a lot better if I line them up. All right, so right off the bat, what I notice is that these two right here both have 3 whole number, like 3 holes, right? $3 if we're talking about money. So know that those two are going to be the highest. I'm going to come over here and rewrite them to the side just so we can see what I'm talking about. Okay, so both of these numbers have $3. And if we look, both of these have 4 tenths, or like 4 dimes, right? So we can't even tell there. They seem like the same amount. But then we're going to go over to the pennies or the hundredths. And that is where we see the difference. 8 is bigger than 2. So I don't even need to look at the 6. I can just tell that 8 pennies is bigger than 2 pennies. So that number is the greatest. And we're supposed to go in order from least to greatest. So I'm going to put this down on the bottom. It is the greatest. And that means the other one that has 3 holes is the next greatest. Okay. All right. So now what I'm left with, I'm going to erase this out of the way. I am left with these two numbers right here. And let's line them up a little bit more, one on top of the other, so we can compare it. It looks like both of these don't have any whole numbers. They both have 3 dimes, 3 tenths, and they both have 4 hundredths, or 4 pennies. So the only difference between these two numbers is the thousandths place. This has 0 thousandths, and this one has 2 thousandths, which means this number right here is the next biggest number. So we're going to put that above, and that means that just the 34 hundredths is the smallest number. Very cool. All right, I hope what that did is I hope that gave you an opportunity to go through those trails, get those synapses firing in your brain so those pathways can reignite and get stronger and stronger so that you can remember this forever and for always. You're awesome. See you later. See you in the next video.